Hello and welcome to another geometry video. We are now in section 11-2 and we're talking about the surface area of prisms and cylinders. So by the end of this video, I'd like for you to be able to calculate surface areas of prisms and cylinders and just be able to use those formulas. So we need to talk a little bit more about prisms and cylinders and their parts, and then we can talk about the formulas and how to use them. First of all, just as a reminder, what is a prism? Well, a prism is a 3D solid with two parallel and congruent bases. And those bases are going to be polygons. Now we do have different types of prisms. We have right prisms, which means that it's kind of standing up straight. And this is probably something you're most familiar with. It's very much so like a box. And then we have an oblique prism, and that one's just going to be slanted, but that's okay. It is still a prism. So just these are our two kind of styles that you're gonna see. Now, the parts of the prism, we have bases. So the base is going to be the two parallel congruent sides. So we're going to have two parallel and congruent sides. These are kind of like, in general, top and bottom. Sometimes your prism will be laying on the side, so it might be a little bit difficult to distinguish where the top and bottom is, but in general, you can think of the bases as the top and bottom if your prism is in fact sitting upright. So in this picture right here, this top part and this bottom part of this pentagonal prism are the bases. So I'm going to say base right here and base right there. Okay, now we also have something called an altitude or a height, and that is going to be the perpendicular distance between the two bases. So the altitude or height, it basically means the same thing. They're almost interchangeable. There's just a slight little nuance, but we're not gonna worry about that. So if we say altitude or height, we are meaning the perpendicular distance between the two bases. Now, if your prism is a right prism like this, then you can just use an edge to figure that out. If it's oblique, then you're gonna have to draw in a separate line. But the altitude, like here, if we did draw in a separate line, it might look like this. So it's just going from the top to the bottom base, and that would be an altitude. Now we also have these things called lateral faces. Lateral faces are going to be the faces or, I don't know, the polygons that are going around the edges of your prism. It's not the bases. The bases are something different than the lateral faces. The lateral faces are the sides of the prism that are not the top or bottom. So the sides of the prism that are not the top or bottom. So looking at our image yet again, I'll highlight this one. This is just one example of a lateral face. This has many lateral faces, but this is one example of it. now that we know the parts of prisms, we can use that to help us get formulas in order to find and calculate certain values about prisms. So something that we do like to find the value of is the lateral area or the surface area, and sometimes both. It's just kind of according to what type of problem you are trying to solve. So in order to calculate lateral area, you are going to need to figure out basically the amount of space that goes around the sides of the shape or of the solid altogether. So first of all, lateral area is the area that all the lateral sides collectively take up. Now, in order to calculate this, what you're going to do, you're going to say the lateral area is equal to the perimeter times the height. So LA stands for lateral area. P stands for perimeter. H stands for height. And if we were looking at this prism up here, this is what we mean. So the perimeter goes all the way around the base. So what's the perimeter of that? And then you're going to take that and multiply it by the altitude or how tall your shape is. So the value that would go up and down along this line, basically. So that's how we're going to find lateral area. Now, if we want to find surface area, that's going to be the amount of space all of the sides take up. So lateral sides and bases. So that's going to be the area that all of them, of the faces of the prism collectively take up. So what we're going to have to do to find surface area is we need to know lateral area still, because that's part of the edges, right? We need to know all the area of all of these sides. But then we're also going to have to add the top and bottom bases. So surface area is going to say the lateral area plus the two bases. Or what we can do, instead of writing lateral, sorry, you can't see. So surface area is lateral area plus the two bases. But instead of saying lateral area, we can just use this formula right here. So surface area is equal to perimeter times height plus 2 times the bases. Now I am using a capital B right here because in some future sections for chapter 11, a capital B is going to mean the base of the entire prism, and then a lowercase b is going to mean the base of a polygon of like a face of the prism. So you do want to be specific. Are you using a capital P or a lowercase p? Are you using capital H or lowercase h? Like make sure as well for B, capital B or lowercase b, because as we progress in mathematics, all of those tiny details become more and more important as what we're learning becomes a little bit more complicated. So here are our two formulas that we're going to use, and let's solve some problems with that now. So in example 1, it says determine if each prism is right or oblique, then label the bases and the heights. All right. So looking at this first one, we're just asking, is this prism standing straight up and down or is it slanted? That's how we're going to determine if it's right or oblique based off of these two examples right here. So it is slanted, so we're going to say oblique. Then we need to find its two bases. So the bases are the top and bottom of the prism. So I'm just going to highlight those. These are the bases, and I will label them as well. So this is a base, and that's a base. And then finally, it looks like we have two options, but remember altitude is always going to be perpendicular to the two bases. So because this is oblique, the altitude is actually going to be this 16 centimeter line. So this right here is the height or altitude. It's not going to be this 20 centimeters because that's slanted. And just think about it like when you go to the doctor or something like that, and they take your height, they do not say, you know, make sure to lean over so I can get your height. No, instead you stand up good and straight, and you don't hunch over anything. And that's kind of what we're doing here. We want the perfectly straight up line, and that's going to tell us the height. Let's do the same thing for this example. Is this a right or oblique prism? It is a right prism. It is not leaning. So it is right. And then the bases, technically this one we could have more than one, but we're going to say it's the top and bottom again. So these are the bases. And then as far as altitude goes, that is going to be, or height, altitude is going to be straight up and down, and it can be the edge if it is a right prism. That's okay. So this 3 right here is the height, this 3 meters. Okay. So that's all we needed to do for that example. We were just kind of looking at the parts of prisms in order to be able to identify them more easily in pictures. Let's flip that paper over and look at the back. We are now going to actually calculate the surface areas of some of these things. So let's rewrite our surface area formula. Surface area for prisms is going to be lateral area plus 2 times the base. But we know that the lateral area is perimeter times height. So I'm going to write this out again. Plus 2 times the base. Now, this B right here means the base of the shape. So we're going to have to do kind of multiple formulas all together. So, let's look at what this B would be. So the base of this cube is actually, like if we were to draw in some lines here, it's this part right here. And if this is a cube, then that means all of the edges are going to be the same length. So the base of this is going to be a square. And we have to ask ourselves, okay, what would be the area of a square? How could we figure that out basically? Well, the formula for the area of a square is length times width, or base times height. You could think of it in more than one way. I'm going to say length times width for right now. But if you do base times height, that's technically the same thing. Okay, now we can actually start substituting in. Let's figure out how wide just one base is. So this is length times width, and if it's a cube, everything is 11 long. So it's 11 tall, 11 wide, 11 deep, all that stuff. So we are going to substitute for length times width 11 and 11. So that's going to be 11 times 11, or 121. 121 is what big B, capital B means. So 121. Big B, that's what we've gotten. Now, if we want to figure out the lateral area, that's going to be the perimeter times the height. Okay, so let's do the lateral area is equal perimeter times the height. So the perimeter of the base is what we're trying to do. So if this is 11, and this is 11, and that's 11, and that's 11, it's going to be 44 around. So it's going to be 44 times 11. And when I put that into my calculator, I get 484. Okay, now at this point, we need to plug these numbers back up into here into our surface area formula. So surface area is going to equal the lateral area plus 2 times the base. So sorry, this 484 is lateral area, okay? So let's substitute into this formula. Surface area is equal to lateral area, well, we calculated that, 484, plus 2, I'm getting that right here, times big B. Well, big base is 121. Okay, once we put that into our calculator, we're going to get surface area is equal to 484 plus 242. I just took this 2 and multiplied that. I'm doing order of operations. Add those up, and we get 726. So the surface area is 726 square inches. All right, let's do that again. For this one, we're going to use surface area formula right here again, but here's the thing. The base, big B, is going to have a different formula this time. So what we have here, we've got surface area is equal to lateral area plus 2 times the base. We know lateral area is equal to perimeter times height, and then we also know that big B. So this time our bases, this prism is kind of laying on its side. The bases are these triangles. That's what's going on here. So the base is actually a triangle, and the formula for the area of a triangle is 1/2 base times height. So this is what I mean. Notice how little b here is the base of this triangle, but big B means base of the whole prism. Okay, let's start plugging our values in. Let's find the lateral area first. So lateral area is equal to perimeter times height. The perimeter of the base is 10 plus 24 plus 26, because this 26 could carry over here. That would work as well. So if I take 10 plus 24 plus 26, that is going to get me a perimeter of 60. And then the height of the prism, I know it looks weird because it's laying on its side, but the height is actually this 13, okay? So we've got this 13, and then when we multiply those together, we get a lateral area of 780. Okay, so 780 is what lateral area is equal to. Now we need to find the base area. So the base is equal to 1/2 base times height. So the base of the base, it's kind of crazy to think about it that way, is going to be 24. That's the base of this actual triangle. So we've got 1/2 times 24 times the height of the triangle, which is 10. The height of the triangle is not the same thing as the height of the prism. We're looking at the prism as being in kind of smaller parts, and then sometimes those smaller parts have even smaller parts to them. So we just have to break it down and look at it piece by piece. So now we're going to take 1/2 times 24 times 10. When I put that in my calculator, I get 120. And this 120 is the area of one base. That's what we just calculated. Now we're ready to substitute everything into our surface area formula. So surface area is equal to lateral area, which is 780. We just calculated that. Plus 2 times the base, which is 120. We just calculated that. Surface area is 780 plus 240. So when we take 240 plus 780, we're going to get 1,020 square feet. Okay. So that's how you find surface areas of prisms. We do need to talk about cylinders real fast because cylinders are going to be a little bit different. They're really, really similar when it comes to the formulas that we use, but a cylinder is different because it has a curved edge rather than all straight edges. So a cylinder, you've seen them, like this would be an example of a cylinder or this, but just in words, how to describe it would be a solid or a 3D solid, however you want to say it, with 2 parallel and congruent circles for bases. Now, cylinders are going to have altitudes and heights as well. The altitude or the height of a cylinder is the same concept as it is for a prism. It's going to be the perpendicular distance between the two bases. So perpendicular distance between the two bases. Okay. Now remember, perpendicular means meets at 90 degrees. I haven't really said that in a while, so I will make a little note just to remind you of that. Okay. Now, just like with prisms, we do have, so remember on the front side of this, we had right prisms and oblique ones kind of were slanted. Same thing here. We have right prisms and cylinders, and sometimes they will be laying on their sides, kind of like a rolling pin, and sometimes they're a little slanted and they're oblique, and that is more than fine. Now, we do have formulas for the lateral and surface areas of cylinders as well. So these are those formulas. The lateral area, or LA, that's the abbreviated way to write lateral area, is going to be 2 times pi times the radius times the height. That is only the distance around the shape, or they kind of look like cans, so around the can. Lateral area does not include the two bases. So I'm going to say that does not include the two bases. Okay. Now we also have surface area, though. That would be everything in the cylinder, all of it. So the surface area would be 2 pi r times the height plus 2 pi r squared. So what we're doing is taking the lateral area and then adding the two bases onto it, basically. In a nutshell, that's what we've got going on. So now let's do that here in our last example. So we're going to find the surface area of each cylinder. So we're going to be using this formula right here. So for this first one, the surface area is going to be, and I'm just going to use this formula right here to write out my numbers, is going to be 2 times pi times the radius. Now the radius is going to be basically from the center to the edge. So this 7 is representing the whole diameter. So radius would be half of that, which is 3.5 times the height. Now the height, because the cylinder is on its side, is going to be 11. And then plus 2 times pi, and then the radius squared, which will be 3.5. So what this is we're saying this is the lateral area plus the two bases. All right, now let's start using our calculators. We're definitely going to need our calculators for this. So if I put this into my calculator, I'm going to take I'm going to worry about pi last. So 2 times 3.5 times 11, and that's going to get me 77. So I have surface area is equal to 77 pi plus, and then here, I do need to square this first, because 3.5 squared means 3.5 times 3.5. So I've got 3.5 times 3.5 times 2, and that's going to be 24.5 pi. Now I'm able to add these up. So I have surface area is equal to 101, ignore that, 0.5 pi. Now we could leave our answer in this form, and this would be called terms of pi because we're leaving pi in the answer. But if we wanted to multiply that out, all we have to do is take 101.5 in our calculators. We're literally just gonna type 101.5 times, not divided by, times, and then our pi key, and then it's not going to be in terms of pi anymore, but it is essentially the same answer, but we're going to have to round it. So that could be Another way to write our answer would be 318.87 square inches. Okay. Let's do that one more time with this cylinder. So we know how to find the surface area. We're going to use this formula right here. So it is going to be 2 times pi times the radius. Well, we have the radius, it's 4, times the height, which is 6, plus 2 times pi times the radius squared. So all I'm doing is plugging straight into this formula right here, just down here for my actual problem. Now I'm going to multiply all of that out. So surface area is 2 times 4 times 6 times pi. 2 times 4 is 8, and then 8 times 6 is 48. So I'm going to have 48 pi plus, okay, 4 times 4 is 16, because that's that 4 squared, times 2 is 32, so plus 32 pi. If we add those up, we have 48 plus 32, which is going to be 80 pi, and then square centimeters. Now, if we wanted to leave it in terms of pi, then this would work. And sometimes your directions will tell you to do that, and sometimes it won't. You'll just have to read your problem individually. And then if we want to get it out of terms of pi, we just take 80, multiply it by pi, and then we're going to get 251.33 square centimeters. And there you have it. All right, that is it for surface area of cylinders and prisms. I hope that this has been helpful for you. And of course, if you have questions, don't forget to bring them to me in class. Bye.